Hi everyone, this is Dr. V. Nirmala, Assistant Professor in Mathematics, Faculty of Engineering, Karpum Academy of Higher Education, Coimbatore. In the last three videos, we discussed about matrices part 1, matrices part 2 and determinant. In this video, we are going to discuss about sets. Generally, the set of all elements is represented as a set, that is collection of elements. Collection of element is called as a set. Generally, it represents by always a capital letter. For example, if you consider A is equal to 1, 2, 3, 4, this is the one type of set. Okay. Commonly used sets are natural number n, that is for example 1, 2, 3, 4, 5, 6, etc. It contains only positive number, and whole number. There is only difference between this one is we have considered only 0, 1, 2, 3, etc. Here also we consider only positive number. And R, that is set of all real numbers. Okay, and Z, the set of all integers. This is the commonly used sets. Generally, the set is represented by three forms. Statement form and roster form and set builder form. If we consider statement directly, like number of even numbers less than 5. What's meaning? The number should be even number which should be less than 5. So we having even number is below 5 is 2, 4. So this is the set. This is called as a statement form. They are given directly this one. Generally the set is represented by the parenthesis like this. So number of even number is less than 5 means 2 and 4. This is the statement form of sets. And roster form. Roster form is here they mention only the statement number of even number is less than 5. So this is called a statement form. Suppose they given directly 2, 4. That all the total number is mentioned in the set form. Here 2, 4 is given directly. This is called as a roster form. And set builder form. Set builder form is nothing but we can mention by always capital letter, not only A, you can take anything. So A is equal to set bracket x such that x is equal to 2n, and here we have to mention the n should be less than 5. This represents the same meaning, that is x should be 2n, n should be less than 5 mean we can take it n is equal to 1, you get 2 into 1 that is equal to 2, n equal to mean 2 into 2 that is equal to 4 which is less than 5. So we have to take it only 2, 4. Suppose you are getting 6 mean it is not possible because you consider only 5. This is called as a set builder form. Now we have discussed about what are the types of sets. Types of sets. First one is finite set. That is, suppose you consider A is equal to 1, 2, 3, 4, 5. Here we can count the number of elements inside the set 1, 2, 3, 4, 5. So 5 elements. So finite count, this will be finite set. Infinite set. What is infinite set? Suppose they given A is equal to 1, 2, 3, etc. There is no end point here. So this is called as the infinite set. And again equivalent set or equal set. Suppose A is equal to 1, 2, 3 and B is also equal to 1, 2, 3. Here the elements of A and B are equal. So this set is called as an equivalent set. And now we are going to discuss about subset. Let us consider the universal set U is equal to 1, 2, 3, 4, etc. up to 10. And can consider A is equal to 1, 2 and B is equal to 4, 5. Now we can take this 1, 2, that is A is contained in U. See, we having 1 and 2 here. Same value also having universal set. So, A is contained V. That is, A is called as a subset of U. Similarly, having the value of 4 and 5 here. This 4 and 5 also is also in universal set, that is here. So, this also B is contained in U. So, both A and B are called as a subset. Then, now empty set. There is no element in the set, it's called as empty set. Here there is no element, so it's called empty set. And singleton set. So there is only one element in the set, it's called as a singleton set. Similarly, there is another example for proper subset. So, what is meant by subset? The element should be in the value of universal set A. Proper subset means, suppose A is equal to 1, 2, 3 and B also is equal to 1, 2, 3. If A is contained in, that is, suppose universal 1, 2, 3, 4, 5, 6, etc. up to 10. Suppose A is contained in B and here the number of elements in this set is 3 and here is up to 10. Suppose the both A is contained in U and A is not equal to U, is called as a proper subset. And now we are going to discuss about operations on sets. That is disjoint, union and difference. Now again consider, suppose A is equal to 1, 2, 3, 4, 5 etc. up to 10 and you can consider this is a universal set and you can consider U is equal to 1, 2 and B is equal to 3, 4. Now you can set U is disjoint V, that is there is a common element. You have to consider only common element of U and V. Here 1 and 2, here 3 and 4, there is no common element. So, this is 0. Okay. Suppose you can take it A is equal to 1, 2, 3, B is equal to 4, 5, 6. Here A disjoint or intersection B is equal to, you have to consider only common element of both sets. Here suppose you can take it 4. Okay. So, 4 and 4 are equal. So, here A intersection B is 4. Similarly, joint or union, here again consider A is equal to 1, 2, 3, 4, 5, 6 etc. or up to 5 and B is equal to 4, 5. Okay. Then A union B is equal to, we have to write only one time in both sets. Here 1, 2, 3, 4, 5. Here having 4 and 5. 4 and 5 already mentioned in A. Therefore, A union B is equal to 1, 2, 3, 4, 5. One more example. A is equal to 1, 2, 4, 8 and B is equal to 2, 4, 6 and 10. So, what is A union B? That is equal to, here you have to consider common element 2 and 2, 4 and 4. So, having union B have to consider 1, 2 again. So, 1 finished, 2 finished, you have to write 4. So, 4 here 6, 8, 10. So, you have to write only one time. So, 1, 2, 4, 6, 8, 10. This is the A union B. And the number of subset for the set is calculated by the formula 2 power m. Here m is represented by number of elements in the set. For example, suppose we having A is equal to 1, 2. Okay. So how many subsets is possible? Here we have to consider 2 power. Number of elements is here 2. 1, 2. So 2 power 2. That is equal to 2 into 2. That is equal to 4. So this will be, you have to consider, or you have to get value of 4 subsets. So A is equal to, always the single value is one of subsets, 1, 2, then pair 1, 2 and singleton set. Therefore, the total number of subsets is 4, 1, 2, 1, 2 and singleton set. Okay, now we are going to see some more examples. We can consider U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we are going to find A dash, then A minus B, A intersection B, A union B. Okay. So consider A is equal to 1, 2, 3, B is equal to 2, 3, 4. Okay. So first you can find A dash. A dash is nothing but the element should be in U, not in A. So what are the elements? Here 1, 2, 3 you are having. So you can write 1, 2, 3 cancel, remaining 4, 5, 6, 7, 8, 9, 10. I am repeating again, the element should be in U, not in A. So 1, 2, 3 already having in U. So 4, 5, 6, 7, 8, 9, 10. This is called A dash. Okay. Then A minus B. A minus B is nothing but the element should be in A, not in B. Okay. So here having A is 1, 2, 3 minus 2, 3, 4. So what is the process? They should be in A and not in B. So here 2 and 2 having, 3 and 3 also having. So the 1 is inside of A but not in B. Therefore A minus B is equal to 1. Okay. Then A intersection B. What is A intersection B? A is 1, 2, 3 intersection 2, 3, 4. Intersection nothing but common element of A and B. So here 2 both having, 3 and 3 also both sets are having. So A intersection B is equal to 2, 3. And A union B. So what A union B? 1, 2, 3 union 2, 3, 4. This will be have to write that we have to combine both the sets, but you have to write only one time each element. So 1, 2, 3 already written 2 and 3. So A union B is equal to 1, 2, 3, 4. And finally we are going to discuss about one more subset example. Suppose having A is equal to 1, 2, 3. So what are subsets are possible here? You have the formula to find the number of subsets. We have the formula 2 power m. Here m is represented by number of elements in the set A. So here 1, 2, 3 having m is equal to 3 here. Therefore we can mention 2 power 3, that is 2 into 2 that is equal to 8. 2 into 4, 4 into 8. So the 8, there are 8 possible subsets of A. So what are subset? A is equal to, you can start with single element 1, 2, 3 and pair 1, 2, 2, 3 and 3, 1. 1, 2, 2, 3. So 1, 2, 2, 3 and 3, 1 and set of 3 elements. So 1, 2, 3 always having one singleton set. Therefore we reached 1, 2, 3, 4, 5, 6, 7, 8. There are 8 subsets of A. Subsets of A. Okay. So these are the possible subsets of A. One more example. Suppose we having A is equal to only 1. Okay. So what are the possible subsets? Here the formula is 2 power m. Therefore here the number of elements in set is 1. Therefore m is equal to 1. can say apply 2 power 1, that is 2. There are 2 possible subsets of A, hence subsets of A is equal to first one single element and singleton element, that is possible subset is 2. Okay. In this video we discussed about what is set and application of set and common usage of set and operations of set and what is subset and proper subset. Okay, thank you for listening.